All right, so get this. Today we're diving into some pretty wild research from Meta AI about large language models, those LLMs.
Yeah.
But with the twist.
Okay.
This research suggests they can actually perceive things like images and audio without ever being specifically trained in those areas.
It really is mind-blowing, right? We're looking at excerpts from their paper. It's 2501.18896v1.pdf.
Okay.
And they're introducing this thing called MILS, which stands for Multimodal Iterative LLM Solver.
MILS?
Yeah, it's basically this new way of using LLMs for things like captioning images and videos, even audio,
Wow.
and generating images from text prompts.
Okay.
They're even doing something called cross-modal arithmetic, combining like concepts from images and sounds.
Cross-modal arithmetic. Okay, I'm already intrigued.
Yeah, it's wild.
But let's back up a second.
Sure.
Before we get to that, how does this MILS thing actually work?
Right.
The paper uses the terms generator and scorer.
Yes.
Can you break those down for us?
Absolutely. Think of it this way. The generator is our LLM. It's like trying to come up with solutions to a task, Like writing a caption for an image.
Right.
It might generate several different options for that caption.
Okay.
And then the scorer, that's another AI model.
Uh-huh.
And it's specifically designed to evaluate
Like a quality control expert.
Yeah, exactly.
Making sure the generator is doing its job properly.
Yeah, that's a great way to put it.
So what happens next?
Well, this is where it gets really interesting.
Okay.
MILS takes that feedback from the scorer and feeds it back to the generator.
So the generator knows what worked and what didn't.
Exactly. Now the generator has a better idea of which captions were closer and can use that info to generate even better captions.
It's like this constant back and forth between
Yeah,
them.
like a refinement process, yeah.
So it keeps going until the generator basically figures it out.
Exactly.
That's really clever.
And you know what's really cool? This whole process means that LLMs can actually tackle tasks they've never been trained for specifically.
Wait, really?
Yeah, it's called emergent zero-shot capabilities.
Emergent zero-shot capabilities.
The LLM can suddenly do stuff like captioning without ever being trained on, labeled captioning data.
So it's learning just through this interaction with the generator and scorer.
Precisely. And the results are pretty remarkable.
So how well does it actually perform?
Well, they're hitting state-of-the-art performance on all these different benchmarks for image captioning, video captioning, even audio captioning.
Hold on, audio captioning too.
Yeah.
So it's not just seeing, it's like these LLMs are starting to hear as well.
That's right. For the audio captioning, they're using a model called ImageBind as the score.
ImageBind.
Yeah, and it can actually map all these different modalities, audio, text, into a shared embedding space.
Okay.
So by comparing the audio to the captions that the LLM is generating, ImageBind can kind of guide the LLM towards those really accurate and relevant descriptions.
I bet they have some pretty compelling examples in this paper.
Oh, yeah, for sure.
Like what?
Well, they show MILS captioning all sorts of images, dogs playing, birds by a window, even like a messy desk with a bunch of monitors.
And these are accurate captions.
Oh, they're accurate. They're grammatically correct, even semantically sound.
Wow, that's pretty incredible considering it's never been trained specifically for this.
It really is. And you know what? They even compared MILS to existing zero-shot captioning models.
Oh, interesting.
And the results were consistently more coherent, more descriptive.
That is seriously impressive.
Yeah.
But we were talking earlier about how MILS can do more than just captioning.
Right.
What else can it do?
Well, one of the most exciting applications is how it can actually improve other AI models.
Really?
Yeah, for example, they used MILS to boost text-to-image generation
Interesting.
by using MILS to, rewrite the text prompts that they fed into existing models.
So it's almost like an editor for the AI,
That's a great way to think about it.
helping it to create a better image.
Exactly, yeah.
Wow.
And it doesn't stop there.
What else?
They also talked about using MILS for things like style transfer in images.
Style transfer.
Where you take the style of one image and apply it to another.
Right, right.
Imagine taking a picture of your pet and turning it into, a Van Gogh painting using MILS.
Okay, that is cool.
Right.
And what about that cross-modal arithmetic we talked about earlier?
Oh, yeah, that's one of the coolest applications.
The whole combining concepts from different modalities.
Yeah, so they gave this example of combining the concept of a crane from an image with the sound of ocean waves.
Okay.
And using MILS, they were able to generate an image of a crane beside the shore with waves coming in.
So it's like they're teaching the LLM to understand the relationships between completely different types of sensory input.
Exactly. It's almost like MILS is allowing the LLM to build this, unified representation of the world that includes both what it sees and what it hears.
And then it can use that understanding to create entirely new content.
That blends those modalities.
This is pretty mind-blowing stuff.
I know, right? The implications are huge.
Absolutely.
But, like any new technology, it's not all perfect.
Right.
There are some limitations.
Okay, let's talk about that.
What are some of the challenges that researchers are still trying to work through?
Well, one that comes to mind is the whole computational cost.
Right, exactly. MILS can be really expensive, especially as the tasks get more and more complex.
All that back and forth between the generator and the scorer.
It takes time, takes a lot of processing power.
So speed and efficiency are definitely areas for improvement.
Absolutely.
And what about the models themselves?
Yeah, the performance of MILS really depends on the quality of both the generator and the scorer.
Okay.
If either one of them is weak, the results are going to suffer.
That makes sense.
So as those models continue to improve, LLMs and everything else, Mills is going to become even more powerful.
So we've got some really impressive results, but there's still a lot of room for improvement and growth.
Yeah, the researchers acknowledge that it's still early days for Mills.
Right.
There's a ton of potential for exploration and refinement.
Well, I'm super eager to see where this all goes. But before we get too carried away thinking about the future, what does all this mean for us right now?
Yeah.
Why should our listeners even care about Mills?
That's a great question.
What's the big deal here?
This isn't just some abstract research project, This stuff has the potential to actually impact our lives, in a big way.
Can you give us some concrete examples?
Yeah, for sure.
How could this change things for the average person?
Well, imagine a world where AI can, seamlessly understand and generate content, not just text, but across all these different modalities.
Okay.
Think about the possibilities for accessibility.
Yeah.
AI that can describe images for people who are visually impaired.
Wow.
Or transcribe audio for people who are hard of hearing.
That would be incredible.
Right. What about the impact on creativity? Mills could give artists, musicians, writers, everyone these tools that help them, translate their ideas into reality in ways that were never possible before.
You're painting quite the picture here.
I know, it's exciting.
Wow.
And what about the potential for scientific discovery?
Okay.
Mills could help scientists analyze these massive data sets that span different modalities, which could lead to breakthroughs in medicine, environmental science, even space exploration.
Okay, you've officially convinced me. This is a game changer.
It is.
But with all this talk about, LLMs seeing and hearing,
right,
does that mean that they're becoming more human-like?
That's a great question, and it's something that's generating a lot of debate in the AI community.
Right.
Honestly, there's no easy answer.
Right.
Mills definitely shows that LLMs can process sensory information in ways that we used to think were, exclusive to humans.
Right.
But it's important to remember that these models are still very different from us.
In what way?
They don't experience the world the way we do, and they don't have our capacity for subjective experience, for consciousness.
So we need to be careful not to get carried away and start thinking of them as little human brains in a computer.
Absolutely. We can't anthropomorphize them too much.
Right.
But at the same time, you can't deny that this research is really pushing the boundaries of what we thought was possible with AI.
Absolutely.
And as these models keep evolving, it's going to be fascinating and maybe a little unsettling to see just how far they can go.
It certainly is a fascinating time to be following AI developments.
It really is. Yeah, it really is amazing to see how quickly things are moving in this field.
It is. And, we were just talking about those impressive results, especially those emergent zero-shot capabilities.
Right.
But I'm still kind of stuck on how Mills actually achieves that.
Yeah.
What's going on under the hood? How does it actually work?
Well, it all comes down to how Mills leverages the strengths of all these different AI models, So, for instance, with image captioning, they used models like CLP and SIGLIP as those scores. And these models, they're specifically designed to assess the similarity between images and text.
So CLP and SIGLIP can kind of understand both images and text.
Yeah, exactly. They do this by comparing the representations of both the image and the text in this shared embedding space.
Okay.
It's they're translating those two modalities into a common language,
Interesting.
So then they can gauge how well a certain caption describes an image.
So it's not just about generating any old caption. It's about finding one that really matches the image.
Exactly, yeah. And for video captioning, they've used models like VicLip, which is kind of an extension of that idea of image-text similarity, but for video.
Okay.
It can evaluate how well a caption actually captures what's going on in a video clip.
And you mentioned ImageBind earlier for audio captioning.
Right.
What's so special about that model?
ImageBind is really interesting because it goes beyond just images and text,
Sure.
It can actually map multiple modalities, audio, text, images, even videos, and depth information, all into a single embedding space.
Wow, so ImageBind can handle all of that.
It can, and that's what makes it so powerful.
Okay.
It allows for this more holistic understanding of the content where the relationships between those different modalities can be, really explored and leveraged.
Okay.
So for audio captioning, that means ImageBind can actually compare the audio input directly to the text captions that the LLM is generating.
Okay.
And that helps guide the LLM towards, more accurate and relevant descriptions.
It's almost like ImageBind is creating this unified sensory experience for the LLM.
Right.
So it can make connections across those different modalities.
Yeah, exactly. And that's where things get really exciting, you know? Think about all the potential for tasks that involve understanding and integrating information from multiple sources.
Right, like analyzing a video that has both audio and visuals.
Exactly. Or even imagine incorporating other sensory data down the line, like touch or smell.
Wow, that's pretty wild.
Right. Mills, especially with the help of models like ImageBind, is opening up all these new possibilities.
It's really pushing the boundaries of what we thought was possible with AI.
It really is, yeah.
But I'm curious, with all these different models at play,
Uh-huh.
how do researchers choose the right combination of generator and scorer for a specific task?
That's a great question, and it definitely requires a deep understanding of both the task itself, and also the specific strengths and weaknesses of all those different models.
Okay.
So, for example, if you're working on a task that needs a lot of creative text generation, you'd want to choose a generator that's known for producing diverse and imaginative language.
Okay.
But if the task involves analyzing complex visual scenes, then you need a scorer that's specifically trained to understand those intricacies.
So it's all about choosing the right tool for the job.
Exactly. There's no one-size-fits-all approach here. It's about understanding those nuances.
And as AI models keep advancing, that selection process is going to become even more important.
It is, because as those models become more specialized, that decision-making process is going to be crucial.
So it sounds like Mills itself is more of a framework than a specific algorithm.
It is.
It's kind of a way of orchestrating the interaction between all these different models, letting them work together to achieve a goal.
That's a great way to think about it.
It's like Mills is the conductor, bringing together all these different AI instruments to create this amazing symphony.
I love that analogy. It's perfect.
Because it really highlights the power of collaboration, even within AI.
It does, and it makes you wonder what other amazing breakthroughs are just around the corner as we keep exploring this idea of collaborative AI.
Yeah, it really is amazing to think about where all of this could lead.
It is. The potential applications are just mind-blowing.
So we've talked about image captioning, video captioning, even audio captioning. Generating images from text, combining those concepts from different modalities.
Yeah.
What do you see next for Mills? Where do you think this research is headed?
Well, one area that I'm really excited about is, expanding Mills beyond the modalities that we've been talking about.
Okay.
So far, the research has mainly focused on vision and audio, but what about touch, smell, taste?
Wow.
Could we use Mills to create AI systems that can actually interact with the world through all of those senses?
Yeah, that would be groundbreaking to have AI that could not only see and hear, but also feel textures, smell aromas, even taste flavors.
Exactly.
That would open up so many possibilities, not just for how we interact with AI, but also for things like scientific research.
Absolutely.
It would be incredible.
Yeah, it would give us a whole new way of understanding the world.
And aside from expanding to those other modalities, what other areas do you think hold promise for future research with Mills?
Well, another big area is going to be improving the efficiency and scalability of these Mills implementations. We've talked about how Mills can be pretty computationally expensive, especially for those more complex tasks.
Yeah, definitely.
But as our hardware and software capabilities keep getting better, we're going to see much more efficient and optimized versions of Mills, I think.
That would be huge for making Mills more practical for a wider range of applications.
Exactly. And I think we're also going to see a lot more research on developing these new specialized AI models that can plug right into that Mills framework.
Interesting.
And that's going to further expand what Mills can do, allowing it to tackle even more complex and challenging tasks.
So it's not just about refining Mills itself, but it's about creating this whole ecosystem of AI models that can work together within that framework.
Exactly. It's a two-way street, As those AI models get more sophisticated, more specialized, Mills becomes even more powerful and versatile. And as Mills evolves, it kind of creates these new demands and opportunities for the development of even more advanced AI models.
It's an incredible feedback loop.
It really is.
A continuous cycle of innovation.
And it really highlights the incredible pace of progress that we're seeing in AI.
It really does.
Who knows what incredible breakthroughs are just around the corner?
Well, I'm certainly excited to find out.
Me too.
This has been a truly fascinating deep dive into Mills and what it could mean for the future of AI.
It really has. It's been great discussing this research with you.
And to everyone listening out there, thanks for joining us.
Yeah, thanks for being here.
We hope you enjoyed this exploration of Mills as much as we did.
Absolutely.
And keep those minds curious.
Yeah, keep exploring.
We'll catch you next time on The Deep Dive.